Okay, good morning students. Today we are going to see the 16-bit arithmetic operation in 8085. Right? The first one we are having the 16-bit addition operation using that 8-bit operation program, 8-bit instruction. Right? Now we'll see that how we are going to do that. We are doing the 16-bit arithmetic operation. Right? So here, what actually we are going to do that one as. Okay. Okay, here we are having the data in okay, we are having the first 18-bit number in 8050 and 8051. This is first number, right? So suppose you assume that one, this is actually we are having now 4292, right? So this is actually we are having now so 92 42 92 42. So that is we are having now 4292. So this is one 16-bit number 4292. This is hexadecimal number, right? 4292. Next one we are having now that in location 8052, that we are having now we have that one as lower bit, right? Lower bit is once again the 92. Here higher bit is 8053. That is in number 11, right? So that is we are having now 1192. Now we have to sum it, right? So we can do that in two ways. One is actually 16-bit operation we can do now as double add. Double add is 16-bit operation. So here instead of that one we are going to use 8-bit operation. Using 8-bit operation, how do you complete that 16-bit addition? That is we are going to see now, right? So first one, here we are going to now, you are doing now 8050, in that 8050 address we are loading, right? So we are having that the instruction is load accumulator. So we are using the instruction load accumulator. Then we are doing now what we are doing now, that 92. So the lower byte 92, the lower byte is going to be loaded. 92 is going to be loaded into accumulator. So we are having now that accumulator is receiving, accumulator means A register, right? So A register we are having now, right? So that is we are having now 80 in from through the direct address. We are having that direct address mode, that from that one we are getting data into accumulator. So that is the operation, right? Sure. Next, what we are going to do now, that whatever that currently we are using now, that accumulator is going to be used for another purpose. So we are moving your data to, instead of the accumulator we are moving your data to P register. So move B comma A. So now we are having that 92 is coming under here, right? So that is also currently 92, right? Next, here we are coming once again then loaded with the next data lower byte, right? So the next data lower byte is here 8052. So that one as is going to be loaded now, right? So that is we are going to have now once again then we are going to move to accumulator. So LDA with the corresponding address. So this is the address we are having now, the LDA with the corresponding address. So LDA with corresponding address we are having now. So 8052 we are going to be loaded. So that is we are receiving now. Okay. Then what we are doing, right? So now that this is accumulator. A register content is the second data lower byte. Then P register content is first data lower byte. Then we are summing. So summing now, right? So we are doing the summing now in the hexadecimal way, right? A plus 2 plus 2 4. Then we are having now 9 plus 9 18. So 18 is we have to see that one as 18. So in hexadecimal form, so what we are getting now 1 comma 2, right? So that is we are having 2 and we are making a carry 2 and you are making a carry. So that is we are having now 24, right? So here we are having 2 4. That 2 4 is in now accumulator and this one is in carry. So 2 4 in accumulator, this one is in carry flag. We are receiving that one, this one is in carry flag register. Okay, so that is, this is in carry flag, cy carry flag is having now that value 1, right? Check. Now we are doing that add operation. Now we have to store the content into 90. So your result is, you assume that one, the result is in 9050. So the lower byte is going to be stored. So we are having the lower byte added. We are getting now that result is 24. The 24 is going to be loaded. So this is, we are storing the content, accumulator content to here, right? So that is accumulator content is currently now a equal to a plus b, right? So that is here. This accumulator content is now 24, right? So this is 92, this is 92, this is 92. So we are getting now the result is 24 and carry flag is 1, right? So 24 and carry flag is 1, right? Then we are having now that 24 is going to be stored in 9050. So that 24 is now moving to that location 24, right? Then we are having now, then we have to take the next higher byte of the first data into that one. The same process we are going to repeat now, right? So whatever that operation we are going to have, that one we repeat that one, and the condition is here ADC. So that code, right? So this is the repetition. So higher order the first data, higher order next data, right? Higher order first data, and we have to move the content into P register. Next higher order next data, higher order we are taking into accumulator, then we are submit. Then in that case now we are using add with carry. So the carry is along with we are adding. So we are getting now the result is here, what it is, 1 plus 2 3, 3 plus 1 4, right? Then we are having now 1 4 plus 1 5, 54, right? Now the 54 is going to be stored in the next location. So that is here 9051. You are storing the accumulator. So very simple, right? So that if you know instruction very well, then we can easily write without any difficulties. So that one as 9051. We are getting now that result is 54 here. So the result is 5424 in hexadecimal form is there in the location, right? Final we are having that halt. So is there any difficulties here? Easily we can complete that one, right? So then after that we can write all instructions, everything we can do now, right? So that is very simple. If you know very well, then this is very simple code. Just we see that one. This is, you know. Then we are having the repetition with ADC. No, right? Then we are storing the content. We are storing the content, and we stop now. Very interesting. Okay. Then you can complete that 16-bit addition operation with 8-bit instruction sets. Now we'll go for 16-bit instruction using 16-bit instruction set. This is very simple than the previous one, right? So we are having now the 16-bit addition with 16-bit operation. So that 16-bit operation is double add, right? Okay. Now that we assume that one with the data is in the same location 8050 and 8051 is having the first element, right? So the same element if you will take now, that is we are having now 92. The next data is 92 42, right? So 42 92. Then we are having now that 8052 is 11 92 92 and 8053 is 11, right? Now we are going to, this is first number. This is a lower byte of first number. This is higher byte of first number. This is a lower byte of second number. This is higher, right? So lower, higher, right? Now this lower higher, that is lower higher HL pair. We have to move that content HL pair, right? So we are having the direct instruction load HLD with the 8050, right? So load HL pair from the address 8050. So that is 92 and 42. So that 92 is coming to lower byte. So that is L register. So L register is holding that 92. Then H register is going to holding 42. So we are getting now that directly loading the HL pair register with our first data. So single instruction. If you know the instruction very well, then we can easily write. Right. Next, we are having now that we know that one exchange HC. So HL pair and the DE pair is going to be exchanged. HL and DE. So HL content and DE content going to be exchange. Why we need to have that exchange? We are going to use that HL once again for another purpose. So now that whatever the HL per content, that content, right? So our aim is this HL data is moved to DE data. So move to DE register. So now the DE register is copying that content, right? So 42 92. So first data we are moving to DE pair. Why? The HL pair is going to be reused, or the register is going to be reused for the next data. So same instruction with that is different address. So second data you have to take. So 8052 is having second data. So this is the second data. Then we can take it now. Can take it now, right? Then simple operation is double add with D, right? So we are having now that one as HL, right? So the contents don't confuse it that one, so you take it as pair. HL equal to HL plus DE. So we are having that content, right? Now the HL plus DE is a double 16-bit operation. So the result in HL pair. So the final result is sum of that result is holding now in the HL pair. Now the HL pair is going to be stored. So for that we are having the instruction is store HLD. Store HL pair content in the location 9050. So in that 9050 and 9051, because of 16-bit, right? We give that one address, then it will store now the H content is here and L content. So this is 24, and here we are having now that value is 54, right? 24 54. Okay, so 92 92, the result is 24, then 1 4 4 2 1 3 5 4, right? So 54. Okay, 5424 is now we are having now 2454 by bit, right? So that H content is here we are having now H content is 54. So 54 is in 9051, then 9050 we are having 2. So lower byte and higher byte is stored now. So result is 5424. Then we can write that usual explanation or usual that one. Here we are having algorithm, everything we can do easily, right? Okay, next is we are having now a 16-bit subtraction with borrow, right? We are going to see that. So if you know very well that previous one, then we can go for easily, you can tackle with that another problem, right? So here we are having now the same cases. We are having that two data in 8050 8051, then another 16-bit data in 8052 and 53, right? The result is we are having now 8054 and 54. Instead of the 9050, here we are going to have that one, right? Now see, here our assumption is here we are having the first data is 6A919. The second data is 5C15. Now we have to subtract. We have to do the subtract operation, right? So how do you do the subtraction? 9 minus 5 4. Okay, then 1 minus 1 0. This is A minus C. So A is 10, minus 12 is not possible. So we have to take 1 from here, right? So 1 from here is in the form of 16. 16 plus 10, 26. 16 plus the A is 10. So in that place we are having that value 26. Here we are subtracting the 12. 26 minus 12, that is 14. The 14 is nothing but E. This is one subtracted, so we are having 5 5, so 0 E. So the result is higher byte is 0 E, the lower byte is 04, right? So that is here, right? So that is 040 E is the result, right? So once again I'll tell that one. Here 9 minus 5 4, 1 minus 1 0. Then we are having now A minus C. A is 10, in hexadecimal A is 10 and C is 12, right? So now we have to subtract. It's not possible, so you have to take a borrow from previous next digit. If you are taking the borrow from next digit in hexadecimal, we are taking 16. So 16, that A is 10. So we are having that now the content is 26. Now in the 26 we are subtracting 12. So we are getting now that one as the 14 as a result. The 14 in hexadecimal form, this is E, right? So 14E. So A is 10, B is 11, C is 12, and D is 13, and E is 14, and F is 15, right? So that is we are having now, right? So now we are going to see that how do you write a code, right? So if you know very well how we are going to do that one, and easily we can write it, no difficulties at all, right? So very easy, so definiteness is there, so we can easily solve that if you are having that much more idea. Okay, next you see that the same cases we are taking the data. First data in HL pair. Now the data is moved to TE, right? Then we have to take the second data in the HL pair, right? So move to TE, then we are release that HL. Now the HL is going to be loaded the next data, right? Then we are having that for taking the faro, then we take that C register content, right? So initialize that one as 0, 0. Why we need to initialize is the randomly it will have the data in C. So you have to, if you are going to use that register, first you have to clear the register. So you take that one as C equal to 0. So we are having that instruction. Whether this is going to be used or not, we are going to see. I think this is not used here in that particular program. We'll check now. Right. Okay. Now here we are having now the DE pairs. So first, right? So we have to subtract the lower byte, right? So you take that lower byte. So in the DE we are having first data, and HL we are having second data. Right now we are going to subtract. So E content is going to be subtract the L content, right? So E content going to be subtract with L content. So that is here. E content going to be subtract with this. So this is we are having now E in E. This is in D. This is L, and this is in H. So E subtract by L first one. So that we are getting now the 0, 4, right? So that is we are going to do. So you have to move, E is going to be moved to A register. So first lower byte is going to move to A register, right? So that A register content. Next we have to subtract that L, HL pair. So A minus L, then we are getting now that A, right? So here there is no borrow at all. Now we are storing the lower byte result in 8050. Now we have to take that higher byte, right? So that D is higher byte of the first data. We are moving to A, then we are subtract with borrow, right? So already if you are having that some borrow, if you are taking now that middle borrow, right? Here that middle borrow is not using, right? So here you see that one, the C register is not using, right? So that the instruction is not required in that case, right? Suppose we are taking now the borrow, then you have to use that one, and we can store it in the another location, right? So next 8054, 8055, and then 8056 you have to store with the C register content. Here you assume that one we don't have any next level borrow, right? That one is here we are having that result, the second higher byte is stored in 8055, and we are halting that instruction. So stop the terminate the program. It's simple, right? So that one is here, right? So you are having now clear idea, then we can say the same program is we are moving now to then another case, right? So in that case this is not required. If you want to have, then we can use the series content, and then you have to take now the borrow, right? So what is the borrow now? Here we are having now subtract with borrow is there, right? So here we don't have borrow. Suppose you check that one here, jump on carry, right? So that is here actually, this is the here the borrow is considered now in the carry flag, right? So the carry flag is 1, right? So that is jump on carry to jump no carry. First jump no carry to the xx, then otherwise you have to increment the register C, then we have to move to xx, right? So now the final, if whether the C content is something, right? So the C content is going to be, so in the after that sta, here you are going to write now move A comma C. So the C is having that borrow, then you have to store the accumulator with 8056. That's all. Then we add these two code, right? So here jump knows in this sequence of code, and this code you have to add, right? So this code is added with that before that store, right? So this is we are going to add before here, right? Then we are incrementing the C register if you are having a borrow. This code you have to add. Then here this code is you have to add now. then we are getting now that the bar also included, the borrow is here, right? So borrow 1, and then here we are having now borrow along with the some data. We can have that 16-bit data as result, and we are having the borrow also, right? Here that multiplication, the multiplication of 16-bit is actually we are having now repeated addition, right? So that is very interesting. Okay, we'll see that. Now the same way, first 16-bit data in 8050 8051, then second 16-bit data in that location, the result is 32-bit data. So here I am going to that one as here. So 0704 0704 is we are coming on 0704, right? So this is first data. The next data is here we are having now 0102. So that 704 is going to be added 102 times. This is a multiplication. This 704 is going to be added 102 times. So we are getting now the result is 32-bit, right? So instead of 16-bit, we are getting now this 16-bit and 16-bit 32-bit as result, right? So 16-bit data and 16-bit data, we are doing the multiplication. We are getting now that one as 32-bit data. Right? Now the 32-bit data is result is here, right? So that is 00071208. So this is the result multiplication. After getting the result, see, this is actually 0007 then 1208. So this is the result as a multiplication, right? Now we are going to get now, right? So that is 32-bit. So this is a higher byte. This one, right? Okay. Next here we are having next one. Next 12 we are having now this 12. Next is 08 we are having here, right? So that is we are going to do that operation. Okay. Now you see at that first data, right? So 0704 0704 is going to have in HL pair. Next, the HL pair content. Now we are going to use the stack pointer is in for another purpose, right? So we are using the stack pointer is for another purpose. Now the stack pointer is not used in the stack. So we are having the stack pointer is 16-bit. The stack pointer is now make a copy of the HL pair, right? The stack pointer. So the stack pointer is not used for their intended purpose. Now we are going to use our purpose, right? So just HL pair content is going to be moved to stack pointer. So we are copying the HL pair content into stack. Save it in stack pointer, right? Not the stack pointer itself. We are having now. We are going to use for storing the data, right? So the difference is if you are having the stack pointer is address, then we are going to store it in stack. But here we don't use the storing in stack. Directly in the stack pointer itself, we are having now that storing the your data. So that is here, right? So HL to SP. So that is SP HL is HL to SP. We are making a copy, right? Now the HL pair is free. So you have to take the next data, right? Now the HL pair is next data, that is 0102. This 0102 also we are going to move to TE pair. So exchange H is TE pair, right? So that is HL and TE is exchanged. HL and TE is going to be exchanged. So that is we are having now the HL pair content. Stop that one. So first data is in stack pointer, second data in TE pair, right? Now the HL is going to be used for addition. HL is going to be used for add. So that address we are going to use, right? HL pair is now act as a accumulator. Accumulator is actually we are using now that here A equal to A plus B. The same way here HL equal to HL plus we are having now the TE content or SP content. HL plus that SP content we have to add, right? So that is we are going to do now, right? So first I told you that one. So if something is there, junk is there, so HL pair is going to be cleared, and BC pair is going to be get the result. Then we are having the So we are having now the carry. So the carry is going to, so what we are having now, the HL pair is going to accumulate. At the same time, the BC pair is used for incrementing. So every time we are making a carry, right? So 704 plus 704, then we are getting some result, then it may have the carry. So the carry is going to be accumulated in PC. Right, then we are having next, the result is there, then once again we are adding 704, like we have to repeat it 1 or 2 times. So we are having getting many carry. The carry is sum up with PC. So the PC is having, at final the PC is having that value, right? So that value is, the at final the PC is having that value is 7 time we are incrementing, getting that carry 7 times the repeated the carry. So the 7 is accumulated in PC pair. In PC pair is going to be increment that one, right? So every time that if you are making a new carry, we are incrementing that PC. So that one 7, if you are adding the 704 1 or 2 times, right? So you are getting one carry here. Like we are having the 7 times the carry is repeated. So that is in sum up with that PC. So that is we are going to have. Okay. Now you see, we are doing the double add SP, right? Double add SP means here actually HL equal to HL plus SP. Then it will affect the carry plug. So the carry plug is no carry, right? If no carry, then we should not increment. Otherwise, we have to increment the PC pair. That's all. The PC pair is whenever we are incur with that carry, then it is incrementing the PC pair. So the PC pair is getting the result 07 at final, right? Then we are here in the DE pair is we are having 1 or 2. So 1 or 2. The one every time we are summing, then we have to decrement the TE pair, right? So decrement the TE pair, and then we are checking now the TE pair whether the TE pair is both 0 or not, right? So for that we are having the 2 code. So now we are checking now the TE pair is, so TE pair is 1 or 2, then decrement that each and every time of the summation, then the DE is going to be decrement to reach 00, 4 zeros, right? Now we are checking that whether it is 40 is reaching or not. Then we have to stop the summation. So that one as we are going to do now. How do you do that one? As this E content is OR operation with the T content. These two content is OR operation, right? Both are 0 0. Then only we are getting now that total result is 0. The 0 flag is set. So that one is we are going to do that one. So this is the operation, right? So OR operation with that D and E, right? So we are doing now that one as in the E is going to be moved to accumulator, and the D is going to be OR operation with that one. The 0 flag is set, right? So no 0, then we have to repeat this repeat the addition. Then if you are having that 0, the process is over. Then what we have to do? So this is HL pair is going to be stored in 8054 and 8055. Then we are having that result, then PC pair is having that another. So the PC pair is moved to once again that HL, right? So now that this HL pair is going to move to the next higher bit. So we are getting now that result. It's very simple. Multiplication is over. Right? So the same code we are having now, that instruction. Now we are going to do that division, 18-bit division, right? So 16-bit division, sorry, 16-bit division, 16-bit number we are going to divide, right? Then we'll see that how do you do that one, right? So that is we are having now the data is there here, input data, right? So this is we are having now 0400, okay. Here we are having now 0400, so okay. 0004. Next one is 0002. The symbol, right? So we are having a division. Division is a repeated subtraction. We are having now, right? So that is result is here. We are having now. So that is here 16-bit division, 16-bit. We are getting now that result is 8-bit, right? So 16-bit, 16-bit. We are getting the result is 18-bit. Sorry, 8-bit. 16-bit divided by 16-bit. We are having that result as 8-bit. So 8-bit that result, right? So 04 divided by 02, we are getting now the result 02, right? So this is we are having now tone care. So that is here we are having that value f of y, we will see, right? Right? So we are having that what operation we are going to do, that one is list out in the algorithm. Then we are going to have the direct code, we'll see that, right? So what we are having now, the LXIH, so we are initializing as clearing that PC pair using that instruction is LXIB00, right? So BC pair is going to be clear, right? Next we are going to now the divisor is here. So the second data, that divisor is going to be loaded HL, right? The second data is divisor, right? So 0004 is dividend, then 0002 is divisor, right? So this is in the location 8050 and 8051. This is having in result the location in 8052 and 8053, right? Now we are having the HL pair is moved to TE pair. Now your dividend is going to loaded with the HL pair, right? Dividend is going to be loaded with HL pair. Then what we are going to have now, that one is, so move this lower HL pair is here, we are having dividend, right? So the HL pair is L, we are having the lower byte is accumulator, and we have to subtract that E, first lower we are subtracting now, right? Then we have to take the second. So this is where the A is the L, right? So that we are, the result is going to be store in L, right? Then we are going to have that one AH, right? So that is, we'll see that one, right? So that is we are going to, okay, what is going on now? This is subtract E, right? So that is we are having now HL and D pair, right? So L and E is subtracted. So we are getting now that one, the 04 and subtract E, HL, D, not say. Okay, L, L to HL pair is dividend, right? So the dividend is 04, 0004. Here we are having 0002, right? Then what we are going to do now as L to A and subtract E. It is dividend. Okay, subtract E, right? So first one subtraction is going to happen now in the lower bit, right? Then we have to do that higher bit, right? So that is we are having now that this result, the A back to L, right? So that is we are having now A back to L here. So that is we are going to have now 0200, right? Then we are having higher bit, you have to take that, subtract with borrow. Then here we are having the TE bar is subtracted, right? Then we are getting now that one, so we have to get now that results. So accumulator content is into move into H, right? So that is we are having now that result, subtract with the result, then we are getting now the H content. So that is the higher byte, right? Then what we have to do is jump on carry, right? So that is we are having now, suppose the carry is occur, the carry is actually we are having now the paro, right? So that is we are going to have now increment at increment PC pair. So we are taking now that borrow, right? So that is we are going to do that, right? Then we are going here what we are going to do now, uh, we are having now jump 800 B, move to after increment, then we have to move to that location 0 B, right? So that repeated 0 B, right? So that is we are going to correct 800B. So move to 800B. Okay. Here we are going to move that. Subtract with the PC. Okay. This is the jump here 80B, right? So that is going to move that, right? Then we have to do that double add with, why it is having the double add is we are making a carry, right? So that is we are having now, this is 004, right? So one time we are subtracting 002, we are getting now that one as result is 002. Then another time we are subtracting 002, then we are getting now the result is 002, right? Then once again we are subtracting 002, then we are getting now that one is actually minus 002, right? So that is going to have the negative number. Instead of that one, the last subtraction is for getting now whether it is the carry is occur now, the for that condition we are subtracting, right? Then once again then we have to add the result, So that I add one whatever the the final subtraction is not necessary, so you are doing that in then another way, just we are adding the same content. So double add with the te with that one, so we are going to restore that value, right? So for that we are doing now the double add, so we are getting now the result in 8056. So we are having that HL pair is going to be right. The HL pair content is we are having. Now the PC pair is we are having borrow, right? The borrow is there in PC pair. Now the PC pair content is loaded with that 8054. HL is stored in memory, right? So at final we are going to halt that result. So that's all. So what we are going to have now, that one as 00004 and 002, right? Then we are doing that one subtraction. We are getting now that 0002. Then we are having that one subtraction is over. Then another subtraction. This is over, right? Then we are getting now the result 000. Even though we are having that another subtraction for making a carry, right? So the last subtraction is not necessary, so whatever the result we are getting now, then we are coming once again then added, so that the subtraction is cancelled. For cancelling that subtraction we are adding once again, then we are taking now that one as the 00 is result, right? Then here in that case the power is in the PC pair. So how many number of powers we are taking now, then that is going to have in the piece pair. As like that we are having now that in multiplication we are having now that carry. Here we are having the division, we are getting now carry, right? So that is we are having now the borrow, we are getting now the result, right? So that is we have to store now, right? So the PC pair is something is there, then we are going to store it now. The result is 8054 and 8056. Okay, we can stop here, then we can continue by next class.